On to question 3. We finished 1 and 2 already. This is paper 2, TZ1, November 25. So, the latest paper, by the way, so we should be good. And this is calc. So definitely get your calculators out and we'll move on. Check out the playlist for 1 and 2 and any videos that come after. Okay. Find data was collected on 2 variables, 8 members of a population, and we have this data. Find the average, so we have to find the mean of x, and then the regression line of y on x. Okay, and we need the correlation coefficient. So let's just set this up in our statistics table on our graphical calculator. What we can do for A is add all of these and then divide by 8, but that takes way too long, and we anyway need to put it into our table for the following questions. So let's put it into our table. So we have x on the left, we have 3.8, 6.3, 2.5, 2.4. Let's do this quickly. 8.9, 10.7, then I have 6.7 and 10.3. Okay, now we go to the y, 11.8, 9.7, 6.1, 4.1, p, which we have to find, and we have, so for p we can skip that and go down to 6. Then I have 23.3, and I have 13.7 and 24.5. And I can now use calculator, one variable, and I found the mean of x is equal to 6.45. So no calculation needed, just put in the values and it gives me the mean. That's our answer. Now B, I, and so for this one I just did one variable, okay, one variable calc, since we have E here, so there's no need to do a second variable. And now we're asked to find the mean of y given we have the regression line. And what we know is that our regression line passes through our point x mean, y mean. So our averages, it passes through those two. This is a coordinate on the line. And so now what we can do is use that line, y, to find y mean, 0.014375 plus 2.1625 times our x mean, which is 6.45. And now let's calculate. And I'll use my other calculator, 0.014375 plus 2.1625 times 6.45. And that is 13.9625. Now we want to put that into 3SF, so 13.9, that becomes 14.0, and that is our mean. Okay, and now we're asked to find the value of p. So we know the mean of y. Now we have to use our formula. We can't use the table. What we have to do is our mean, so that is 14. Let's use 13.9625. We always use the value stored in our calculator times, we have 8 values, and that is equal to the sum of everything, right? That is what our mean means. So 11 point. So essentially p is equal to 8 times our mean, 13.9625, minus the sum of everything else other than p. So 11.8 plus 9.7 plus 6.1 plus 4.1 plus 23.3 plus 13.7 plus 24.5. So now you just stick that in your calculator. And I would say first work this out. So you show your steps, 11.8 plus 9.7 plus 6.1 plus 4.1 plus 23.3 plus 13.7 plus 24.5. And I get 8 times 13.9625 minus 93.2. And that is, let's calculate, 8 times 13.9625 minus answer. That is 18.5. Right, so P is equal to 18.5. That is our answer. And now we have to go for C. Let's go for C. Hence find the Pearson's product moment correlation coefficient. And so that is something we cannot just calculate by hand. We need to use our calculator. And so what we need to do is replace our P in our calculator with, was it 18.5? So we have 18.5. Okay, something happened to the rest of my, so I'm just gonna stick that in, 13.7, and then I have 24.5. Let me see if that's correct. Yes, so instead of P, we put in 18.5, and this is in our statistics section. Then we press enter, we say double to variable, and we have, you can check what your mean is. My mean is coming as the exact same, 13.9625, and that is what we had, so that verifies. And we have mean of x exactly the same. Now what we're looking for is r. Okay, and actually what we want to do is not go to calc, what we want to do is go to graph, right? I'm using the Casio FX CG50 calculator, by the way. And so we want to go to graph. Let's do graph 1. And then let's go to calc. And then, so let's do steps, right? 1, 2, and 3. Then on calc, we want to go to x. And we want to choose x, and we want to do ax plus b. That gives us our linear regression. And definitely check your settings, and how you do that is go out, when you press graph, go to set on F6 and make sure it's list 1 for the X and list 2 for the Y. Choose scatter for your graph type, and everything should work out there forward. And so what I get now is R is equal to, that's why it's 1 mark, it's given to you, you don't need to calculate anything. So R is equal to 0.95395.832. Hopefully you get something like this in your calculator, but what we want to do is give that to 3SF, so 0.954, right? 3SF. And so that's perfect. That is how we do question 3. Now I'll move on to question 4, and what we have is, consider the function gx is equal to a cos bx minus 3. Element of all reals, element of all real, okay. And then what we have is the following diagram shows part of the graph G. G has a local minimum at 0, -8, okay, that is here. Local maximum at 16, 2. Find the value of A and B. And so we have a sinusoidal, or cos graph. And so this is our maximum, this is our minimum. That means our amplitude is half of this, right? And amplitude is A. So A is equal to, we say 16 plus, but we have -8, so -8 divided by 2. And what we get is 8 divided by 2, 4. So 4 is, sorry, I mixed that up. What we have is our y coordinate is -8, sorry, and y coordinate is 2. So what we need is a is equal to r2 minus, right, we want this distance, so 2 minus -8, that is plus 8, 10, and we have over 2, right, we want the half of that, so that's 10, 5, a is equal to 5, and hopefully that makes sense. That means we have our midpoint somewhere here, and that is about 5 from -8, so -3 should be, right? That's -8. This is -3, and this is 2. Okay, so 5 gives our amplitude, and now we have B, where A is greater than 0. But an important thing to remember here is we have a cost graph, so we need to make sure that our cost graph is sort of in this path, not this way. That would make it negative. Sorry. If we had, let me say this. If we had this would make it negative. And we have a horizontal shift of +3. Okay, a vertical shift of +3. And horizontal stretch. Okay. Sorry, remind me. This should be a is equal to -5, right? Which is what I just discussed. Our regular cost graph would be here, right? And so we're having a flip. There's no horizontal shift. So that means we are just having a reflection in the x-axis. Reflection of cos x in x-axis means we have a negative amplitude, negative coefficient. So that's our amplitude is equal to 5, but it should be -5. So amplitude, we can say, and so this is our answer. Hopefully that made sense and I didn't confuse you guys there. And now we have BB greater than 0. Now B is our vertical shift, and is our horizontal, okay, not this. B is our horizontal stretch. Stretch, or rather compression, right? And so we have our formula. Time period is equal to 2 pi over B. And so our B is equal to 2 pi over T. And what is our T? T is this, right? This times 2, right? We want one full wave. And so that would be 0 to 16 times 2. So 16 times 2, that's 32. And what we have is pi over 16 is our B. So B is equal to pi over 16. That's part 2. That is our answer. And this is our other answer. A is equal to -5. Hopefully that's clear. And next is write down the smallest positive value of the constant k such that g of x plus k is equal to g of x for all x. Smallest positive value for constant k. So it's plus k, so that means we have a horizontal shift of k to the left, right? K to the left. Now we need to look at where would we have this same graph. Let me delete all of this. Right, where would we have this same graph come back again? So we know that this time period is 32, right? For this period. And then we want shift to the left. That means we have this. We want this to come here. So how much would that be? That would be 32, right? We have a peak here, a peak here. We want that to come here. That is, again, 32. Hopefully that makes sense. And so k is equal to 32. That's our smallest possible positive value. And then what we have, the function g of x can be written in the form this. So now we need to change it into a sine graph. And we have smallest positive value of q, this. And for this value of q, find the value of p. So we need to find everything. So now we need to equate this graph to our sine graph because it can be written as this. It is the same function. So a we found was -5 cos pi over 16, right? Pi over 16 x, and then we have -3, and we have that is equal to e sine. B is the exact same, so 16 x minus q minus 3. And so simply we can just cancel these, and our amplitudes should be the same, right? The vertical